So I'm going to solve this Hackerrank challenges. Hackerrank challenges in the history because I forgot. Hackerrank challenges in the history because I forgot. Hackerrank challenges in the history because I forgot. I think I'm gonna spend probably 1 hour on each of them. I think I'm gonna spend probably 1 hour, and then if I can solve, I'm just gonna look at the solution, and I'm gonna try to do as many as I can, and I'm gonna try to do as many as I can. Probably, and I'm gonna try to do as many. I'm not sure as well. I'm not sure as well how long I'm gonna spend on Hackerrank. How long I'm gonna spend on other sites. Hackerrank. How long I'm gonna spend because I think the one that I spent most time with so far is Cold Wars. The one that I spent most time. And I think I did one problem in Hackerrank. And I think out of the two, I enjoy more solving. And I think out of the Cold Wars, I enjoy more solving. But Hackerrank seems to be better for interviews. But Hackerrank seems to be better. Jesus. Okay. I'm also gonna stream the dark because I don't feel like opening the curtains. Too much reflection on the screen. I'm probably gonna put some music here as well.
Yeah.
Hopefully I don't get.
Come on.
I think I'm just gonna put it for myself and not the stream so I don't get copyright striked. Alice and Bob each created one problem for Hackerrank. A reviewer rates the two challenges, awarding points on a scale from 1 to 100 for 3 categories: problem clarity, originality, and difficulty. Oh, the other thing that I found was this site here, that I think I'm gonna do off-stream because it's probably paid. I think it's paid actually, from what I seen. But I think I'm gonna write it down here. They have this thing where they show you which ones are, how can I say, which challenges companies do more often based on the category. So I think the top ones are this one, DF is depth first search, which is a tree search, a form of a tree search. Then you have basic programming. I think I'm gonna focus on these ones the most, obviously, because it's higher ROI. But I'm also curious to see dynamic programming. I'm gonna put it here because I thought that from all the ones I've seen so far, it seems to be the hardest. And I like doing the hardest ones because when you do, obviously when you're capable of doing the hard ones, the easier ones become even easier. So as I think that's all of the ones that are tested the most. Greedy, I'll have to see what is that later. Hash, I think, is objects. And heap. Yeah, so let's go back to the challenge. A reviewer rates the two challenges, awarding points on a scale from 1 to 100 for 3 categories: problem, clarity, originality, and difficulty. The rating for Alice's challenge is the tripled A equals A0, A1, A2. And the rating for Bob's challenge is the triplet B0, B1, B2. The task is to find their comparison points by comparing A0 with B0, A1 with B1, and A2 with B2. So if A bigger than B, then Alice is awarded 1 point. Otherwise, Bob is awarded 1 point. Neither receives a point if they're equal. Comparison points is the total points a person earned. I should probably put the timer here as well, so I don't go over 1 hour. Given A and B, determine their respective comparison points. For elements, Bob is awarded a point because A is 0. I don't understand this. For the equal elements A1 and B1, no points are earned. Finally, for elements true, A true bigger than B true, so Alice receives a point. Oh, so we're just explaining this scenario here. So for the 0, I think this is a typo probably. I'm not sure. But Bob is awarded a point because B3 is bigger than 1. Okay, so it's just the explanation. Function description. Complete the function compare triplets in the editor below. Compare triplets has the following parameters. Int A3, Alice's challenge rating. Int B3, Bob's challenge rating. So this is the function I have to write here. I'm going to receive A and B, which are true arrays, and I have to compare both. So obviously the first thing that comes to my mind is loop, nested loop, and then that's O(n), I think, O(n) square, because the complexity changes according to the size of the array in n, and because you're doing true loops, it's going to be n times n, which is not the best. Then I think probably the best is storing the information and then using that storage to compare. But maybe there's an easier way. I think I'm gonna do the easiest way I can think of first, and then I think about it the more complicated ways. The first line contains 3 space separated integers, the respective values of triplet A. Second line. Or I can just do one loop, in range, length, because they're both gonna have the same length. I don't remember if I can compare in Python by using this. Probably I can. So what do I have to do again? Compare. So I have to do another variable, I think. Result A, result B, and then I start a score on these variables. So if A is bigger than B, then A gets a point. Result B plus equals 1. Oh, maybe I should test to see if they are both arrays as well. I'm not sure if I need to do that. Because what if they pass another input that is not an array? But I don't think that's necessary. Then I don't do anything. I think if they're equal. Also, I need to return an array of both scores, I think. I don't think I need to put the last condition. can just return result A, result B. Not sure if that's what I have to do. Oh, that's it? No, I don't know if they test for all the cases here, or if it's just like Code Wars where you have the easiest cases first, and then they test for a bunch of others when you're gonna submit. But I think I'm gonna try to submit this already, because it's just one loop that I'm using here, so probably not gonna be able to get any better than this. And it seems like this might be one of the easiest ones. Oh, nice. Yeah, I think this is the easy one. Easier ones still. Probably should take more time when I get to the hard ones. In the challenge, you are required to calculate and print the sum of the elements in an array, keeping in mind that some of those integers may be quite large. Function description: complete a very big sum function in the editor below. So the size of the integers, I think, is just important when you're using C++ or another interpreted type language where you have to specify which variable we're gonna use. But Python, I don't think you need to do that. And then if you had to use the big number library, I think they would tell you to write up here as well. Not sure. Long integer array R as a parameter. Okay. Complete the a very big sum function in the editor below. It must return the sum of all array elements. A very big sum has the following parameters. Okay, so just sum all of them. It seems to be too easy doing this. I think it's sum R. It's probably a catch here that I'm not understanding. Complete the a very big sum function that is below. It must return the sum of all array elements. A very big sum has the following parameters. The sum of all array elements. The first line of the input consists of an integer n. The next line contains n space separated integers contained in the array. Return the integer sum of the elements in the array. Yeah, a lot of this, the biggest issue I have, biggest problem I have with the challenges is understanding exactly what they want me to do. I think I also had this problem on Code Wars. Sometimes it's hard to know what exactly they want. I don't think it can't be this easy. There's something I'm missing here probably. Oh, it passes? So it's probably for other languages, this one. The range of 32-bit integer is this. When we add several integers values, the resulting sum might exceed above range. When you use long int, C, C++, Java to start such sums. Yeah. Okay, nice. I think this is are the easy challenges as introduction probably to the site. I probably have to pay for this, and this one I don't want to share stuff. Okay, so how do I find more challenges? I think I'm gonna go through here instead of here. Might be better. I wonder if there's a way to... Okay, here. I should probably try to do the hard ones first. Usually that's the way that I like to do things. Try the hardest thing that you can find, and then I probably won't be able to do it, and then I can figure out what's the direction I want to go based on that. So always begin with the end in mind. Find the maximum possible value out of the equation provided. Validating postal codes, matrix script. I think I'll start with this one. Read input from standard in, print output to standard out. So I'm probably gonna have to use the sys library. You're given a function x to the power of 2. You're also given k lists. The if, I don't know how to say this, but you get it. List consists of n I elements. You have to pick one element from each list so that the value from the equation below is maximized. And this seems like it's gonna be difficult. Okay, so I have a function, and I have probably a list of lists. Oh, I forgot to change the clock here. I think I'm gonna spend 1.5 hours on this one, because it's probably very hard. You have to pick one element from each list. So I have a list of lists, and I have to select one element of each, so that the value from the equation below is maximized. Xi denotes the element picked from the if list. Find the maximized value as max obtained. So isn't it just finding the highest element of each one? I don't remember if there's a method for that in Python. Note that you need to take exactly one element for each list, not necessarily the largest element. You add the squares of the chosen elements and perform the modulo operation. The maximum value that you can obtain will be the answer to the problem. The first line contains two space separated integers. The next k lines each contain an integer and I, denoting the number of elements in the if list, or whatever you say this, followed by n I space separated integers denoting the elements in the list. Output a single integer denoting the value as max. Picking 5 from first, 9 from the second, 10 from the third. Okay, so the hardest part about this is understanding how to structure this. So I have a function, but do I put the function here? Fn t, and I think those are the true parameters. You're also given k lists. The list consists of n I elements. You have to pick one element from each list so that the value from the equation below is maximized. Xi denotes the element picked. If list find the maximum value as max obtain. So I think the function is gonna be this one every time. Because what would make it a lot harder would be if they pass a different function each time. Then it would probably be extremely hard. So I think that's the function every time. There's nothing I can read here that clarifies the thing. So it's maximum of 7 lists. Trying to think if I'm gonna have to use a nested loop or if there's a way out of it. Or maybe I can research highest value of a list, Python. I think it's probably max. Yeah, max in the list. Because if that's the case, then I can just loop through the first one from loop through k and then implement max on each list and then run the function. It doesn't make a lot of sense. Oh, yeah, should be caps lock here. Oh, I need to put... Actually, I need to put this max on inside the function. So there you go, I think. I think I'm just gonna try to run and see if that's what they want. And then try to figure out from the mistakes. No. Put standard in. So that's the issue here. I'm not understanding what they want exactly. I think I need to use probably some library to get the standard in and display standard out. Yeah, sys standard in. Can be used to get input from the command line directly. It is used for standard input. It internally calls the input method. So I can just run this loop here. So maybe it's the same logic, it's just the way that I was doing. Oops. Just a little bit different. So I think the input is given as a string. And that's why this R strip. But then the issue is, I'm not sure if I should, because it says here you're given a function. So I think they are gonna put the function on the standard input under the hood. You're also given k lists, which are the inputs as well, I think. So maybe the function doesn't, or maybe I don't need the function at all. I think I'm just gonna try to erase this and use this here. So line strip is gonna be equal to k, I think. Which is the list with the number. Well, actually, I need to take the max of this. Because this is probably gonna be a list with the inputs for each iteration. But then, how do I put this on the function? You're also given k lists. This contain consists of I elements. You have to pick one element for each list so that the value from the equation below is maximized. Well, that you need to take exactly one element from each list, not necessarily the largest element. I also don't understand what they mean by this. What's the element picked from the if list? I think I'm gonna have to look this one up. It's not that this is hard, I think. It's just that I don't understand what they want. First line contains two space separated integers k and m. Okay, the first line contains two space separated integers k and m. Next k lines, which contains an integer and I. Oh, so I think, yeah, that's probably why this is difficult. So the first line contains two space separated integers k and m. Denoting the number of elements in the ith list. Followed by ni space separated integers denoting the elements in the list. Okay, so the first true is, so when line equals 0, or in the first iteration, we're gonna have k, m. They're both integers. Contains integer ni, the number of elements in the ith list, followed by ni space separated integers denoting the elements in the list. So x, b, z, s. Just gonna put any letters here, just so I understand what's going on. So I think that's the inputs that I receive. The next k lines, each contains an integer. So I probably shouldn't take this integer into account. So I think it's better to remove the first number, first element. Yeah, but so here I'm gonna do key enumerate. I'm gonna make if key different than 0, to skip the first line. Then k dot pop 0. I don't remember. Should probably look it up how to remove the first element. I also should see if I can print stuff, so I know if line is what I think is gonna be. I should also erase this. Okay, so at least I have an output there. But I don't think I can. Okay, so k is a string. Yeah, I can't use print statements. That's the issue. Uh, oops. So I think this is gonna split the string. No, the imp not for 0. It's gonna transform this string into an array. Yeah, so I'm not gathering any errors, so it means that the input, the imp, is a list. So I think I have to do this function as well. Return x true. And now I need to sum them or get the max. Should probably. But I feel like this is not gonna be the answer. I'm gonna change this music. I think it's just his standard out probably. So it's probably sys dot standard out dot right. I don't feel very confident about this one, but I think I'm gonna run, see what happens. Hmm. So imp is still a string. Don't understand this. Maybe I should read the standard in again. Oh, I have to remove this new line as well. Oh, okay, so this is what this does. I don't think I need to put new line because I'm gonna the standard out is gonna be only one line. Oh, maybe I need to convert it to a string here. Yeah, but then it doesn't make sense. I think that's also something I have to do, but the mistake I'm getting is here. Which doesn't make a lot of sense. So maybe I just need to put it without this thing here. The other thing is that it looks like the output's also not working because I'm not outputting anything. Oh, it's probably because of the error here. Hmm. Thing is, if this is working, if this is not working, how is the other things working here? It doesn't make sense. I'm also not putting the stuff in the function. Let me erase this line, see if anything changes. Probably not, but... Well, now I'm getting no response here. Interesting. Trying to think what I can do without using the print statement to understand what's going on. Because I don't get it. I don't understand how it's working here and then it fails here for some reason. I guess this method is for strings, but it just removes the new line. But this one should be failing if... Or it should be transforming this into an array. Like here. Oh, it's because it's an array of strings. That's why. So maybe it should transform into an integer first. No, well. Yes, so how it should transform string into integer. And I should probably use try as well. I think it's just int and then the string. Like this. But I'm not sure if that's gonna work. Because, yeah, the issue with doing this is that I can't split then. Yeah, it probably doesn't work. I'm trying to think about a way that I can do it without having to put another loop here to transform each element into an integer. I can just do... Oh, yeah, but then it doesn't work. Let me think. I can use filter as well. Yeah, but then I'm still looping twice, I think. But instead of using the max, I can use filter and use a lambda. And transform and use the lambda. So I think in filter, the function... Yeah, the array, the list comes here, and then the function comes here. I always confuse the two, which ones comes first. Or maybe filter is not the best as well. Because I will have to use max as well. So function comes first and then the array. Yeah, but the thing here is, because I'm gonna have to do, and maybe filter is not the best. Because if I have to compare true, I have to create a variable outside and then store in that variable the highest value. And then I have to make the value equal to 0 after I do the sum. So it works on the next loop. So I'm just trying to think if there's any other ways. I want to transform. Oh, actually, I can replace this here. And then I can get rid of this line. And then I can put this as imp. I think that's what I was trying to do. Because I want to transform them into integers. So I can't use filter, I have to use map. And then I get the max here. And see if this works. Okay, at least it doesn't fail. And I'm getting an output. Oh, I forgot to put on the function. So I need to do fn here. Nice. So it was actually a lot easier. Let's see if it passes all the other ones. Oh, too good to be true. They just passed the easiest one. So what could be wrong here? Maybe I'm not testing for different inputs. I also don't understand this first line here. The first line contains two space separated integers. Like, what's the point of this one? So maybe that's the thing that I'm getting wrong here. Maybe I should do if equals 0. Oh, but then it's the same thing that I'm doing. Oh, that's the problem, I think. I forgot to pop the first element. So I'm gonna move this here. And then I'm gonna put else. I don't know if we can do it on the same line. And I'm not sure if I should add this first line here. So the next ones I need to remove the first element because it's not part of the list. And then the first one I keep the true. Oh, M is the modulo operator. Oh, never mind. So actually, well, let me think. Yeah, I'm gonna do k equals. Oh, actually, I'm gonna do km. Actually, I don't need to put here. Km equals. Actually, I'm gonna copy this line here. And I think this is gonna make k equals the first one and m equals the second one. And then here I need to do this m. Yeah, let me see if this runs at least. Intent string. Oh, again, I have to transform here. So I think I'm gonna do this outside of here, just so. Yeah, now I think at least it's gonna run. Okay, I'm getting 38. I'm supposed to get 206. Hmm. Don't know if I should be using this K as well. Be right back. Go turn on the lights. It's almost night here. So I don't know exactly what I'm doing wrong here. I think this part is correct. Probably. And this one too. So it has to be... Oh no. Okay, thank God. So that should be here, that is the problem. So it might be because of this pop thing that I'm doing. I wonder if I can put this on the same line here. And then just the line here. It doesn't change anything though, that's the problem. It's just the same thing. Oh, I am putting in the function here. Fuck. Right back, I have to clean this stuff. I think the energy drink became ice and then it went everywhere. Thankfully I have I don't know how to say that, but blankets or something like that. so it doesn't go everywhere. And so this doesn't change anything. But I think at least doing like this looks nicer. Let me think. So what is the input here? I guess it's all of this. So it's 10, 9, 5, probably. Yeah. Okay, so I don't need to take the first. Oh, but isn't the expected output the remainder of the thing? Maybe I should remove this from here then, but then I'll still get 38. Should probably leave it here. So what am I doing wrong here? Yeah, I have no idea. It looks right to me. So I'm getting 38. It doesn't. There's no sum here that makes sense. It's 5 is 25, then 9 is already. 9 to the power of 2 is already 81. Already surpasses 38. I'm trying to understand why I'm getting 38 with these numbers here. What if I sum them up? It's 15, 20, 24, 33. Also doesn't make sense. Oh, 33, 36, 38. So maybe I'm summing all the numbers instead of getting the maximum. And I'm also not removing this one. Let me see if I remove this pop here. Ah. Yeah, but then it's not gonna pass on the other ones. Okay, at least I'm passing one more now. I'm still failing on all the other ones. And hopefully this thing doesn't... Okay, I'm passing 4 tests now. Which is better than just one. So I think I'm on the right direction at least. What else can I be doing? wrong here? I guess it's probably the case where the first number is bigger than the other ones. That's another case that I have to solve. So maybe I should just search for how to remove first element with this Python. Or I can make the element equal to 0. It might be an easier solution as well. I can do just line 0 equals 0, because then it's always going to be less than the other numbers, but I also want to see how to remove it. But let me see if I pass any other tests doing this. It's still the same thing. So which cases I'm failing? I think I'm stuck because I can't see what is wrong here. I think, yeah, the other thing I could do is do checks to see if the input is what I think it is. Yeah, pop 0 should remove. I think it's just type and then the input, but I want to make sure. I think it's just like this type and then the thing. I wish you could print the line to see what it is. And so far, I enjoy Code Wars a lot more than this style here. The thing is, I don't know as well if the interviews they allow you to print stuff, or if it's just like this, where you just have to figure it out without debugging. But it doesn't make sense to me if it is like this. Because it seems like debugging or figuring out what's wrong is a core part of being a developer. So I don't understand why companies would prevent people from doing this kind of things or even researching. I think it's just type. I guess one thing I can do is also remove this line and then use cstandard out to print the line so I can see what it is. I think that's a good idea. I didn't think about this before. I'm thinking about checking the type of the line to see if it's a list or not, but I think it's better to just do what I said. Just do this and then line here. Because I want to make sure that I understand what this line is. Must be a string. Okay, so it is a list. But I think I'm gonna do this to see. Oh, I don't think I can do that actually. Oh no, yeah, looks like I can, so. Yeah, so the first one I'm getting 0.54. Oh yeah, because I'm making the first one equal to 0. Yeah, 0.789.5. So it looks like I'm getting the correct input. So maybe I should just look at the solution because it's not that I don't know how to do it, it's just that it seems like I'm doing it right, and it's one of these things that I don't know what I don't know, so that's the problem. Oh, the other thing I can try is to check the inputs. That was what I was thinking about. You're given a function, you're also given k-lists. It also says here I'm given a function, so this might be the issue as well. Because the function might be given through the input. Yeah, but here it doesn't show any function. So I guess this is probably correct. We should take exactly one element from each list, not necessarily the largest element. So maybe if I remove the max here. Oh, so it's probably because of negative numbers, I think. Because if you have minus 200 and then the positive numbers go up to 100, then obviously minus 200 is going to be bigger because it's to this. So that's probably what I'm getting it wrong here. So maybe I should do absolute first. I think yeah, it's just abs. So I'm gonna do this here. So that way I get the highest one. So maybe that's gonna help me pass more tests. Let's see how many. Or it's still the same amount. Hmm. So the other thing that I can think about is the size of the integer. I wonder if I can do, I probably can't do long int here. It doesn't work. Maybe I should import. It doesn't seem like this is what's wrong. Oh, I think I know what's wrong. It's because I'm not thinking about. Maybe I'm overthinking here, but I think the issue is that I'm not thinking about the remainder here. So, in some situations, it might be the case that even though I'm getting the maximum, the highest value of the list, because it's odd or even, and I get the remainder becomes a smaller number, I think, which makes things a lot harder. So that could be one thing, and the other thing is the size of the integer. Yeah, but I'll have to think a lot more to think about a way to deal with this. Yeah, because there's no clear way of, unless I test multiple of them, but then because that way it's gonna get too big. If I have to test every single number to see which one is bigger, I think the solution just becomes too big. Maybe it might be worth it to give it a shot with the worst solution I can think of that just works, so that I can see if that's the case or not. If I pass more tests doing that, or if I'm thinking the wrong way. But I'm not sure if that's the case because I'm always getting the remainder divided by a multiple of 10, which means that the highest it's gonna have to be it's gonna round up every time, I think. Like it doesn't matter because, but maybe it does matter. I'm not sure. I so far as I think it doesn't matter because if I get smaller number, it's gonna be rounded down anyway. But maybe not actually, because the remainder gives me the remainder. So yeah, it might be the case. Yeah, because it's gonna divide up to the amount that it is divisible for, and then it's gonna get me the distance, I think. It's kind of hard to think about that. Let's see, I think I'm gonna write it down to, let's say it's have 55 remainder by 5 is gonna be equal to 5, I think. Then 57 remainder by 10 is gonna be 7, I think. Yeah. So that's why they're saying here is not the largest element. Because you need to get the element that is going to be closer to to a multiple of 10. So closer to 9, I think. The sum has to be closer to 10. So maybe you should get the sum of them first. Yeah, but it's not the sum of them, it's the sum of them after they go to the function. So I should remove this max here. Yeah, but that's the problem. I think I have to put this function inside of the lambda here. And then I don't need the absolute as well. Or maybe I can parse inside this function is probably better, actually. I just do like this, and then I don't have to. I can just do fn here. But then I have to use lambda as well, I think. Because I have to pass the argument. Yeah, it doesn't change anything, probably. Okay, so let me think. So imp is gonna be a list of all the final numbers. And then out of this list, I need to find a combination where the remainder is the highest. The remainder of the sum is the highest. So maybe I can do a while loop. I don't think I can escape from using another loop, probably. Because I have to check the combinations. Trying to think if I can store them in an object or something like that. Oh, the thing is, yeah, I'm actually getting confused because I forgot that this is for each line, so I'm gonna get the sum of all of them through each line. So maybe if I append, I make this equal to an array and append to the, yeah, but then it doesn't make sense as well. Because I need to get the combinations. I guess I can append this to the result. I can append each list to the result. And then results are gonna be a list of lists. And then I can do some, then I have to think about an operation that allows me to check for the best combination outside of the other loop. Let me think. See how long I have. Do 8 minutes only. Trying to think if I can use NumPy to do something with matrices to find an efficient way to test all of them. All of the combinations of the sum of each list. So I get the highest remainder. And this deceivably difficult. It looks a lot easier than it is. It sucks. I think I'm gonna have to look it up. Look the solution. Oh, I can look at the other submissions. I think. And the only way I can think is by doing a while loop and then checking every combination to see which one is the highest. But then I would have to loop through both lists. It just seems to... It's definitely not the best approach. Because I would have to put two other loops and then check the sum for each one and then compare the sum for each one. I know it's not the best solution. There's probably some trick in mathematics to find the highest one that I can think of, the highest remainder. Some multiple of numbers. Yeah, I'm gonna have to look it up. There's time's almost up and not gonna be able to solve this this time. Usually the hardest questions involve some type of trick. I think what I'm gonna do after this question, after I look it up, is just study the topics I have here, because I'm a little bit tired already from doing these challenges. I need to see which one. So data analysis. Yeah, I remember this one being very difficult. So I think that's probably the one that I'm gonna do first. Data analysis. Yeah, Spearman rank correlation. I remember not knowing how to do this. I think this is one I can do it. Not sure why I wrote it down here. Oh, so this is my submissions, I think. I'm not sure if I remember the name of the problem as well. I think that these are solutions from the problem. It seems to be KM. Input split. So part products. I'm gonna search what this is. I know ether-tools is very useful. I think I used a couple of times in some projects, but I'm not very familiar with it. For efficient looping, this module implements a number of iterator building blocks inspired by constructs from APL, Haskell, and SML, which has been recast in a form suitable for Python. The module standardizes a core set of fast, memory-efficient tools that are useful by themselves or in combination. Together, they form an iterator algebra, making it possible to construct specialized tools succinctly and efficiently in pure Python. For instance, SML provides a tabulation tool, which produces a sequence. The same effect can be achieved in Python by combining map and count. Gonna look at another one. So it's used to get the product of two sets. Cartesian product. So it just returns the combination of all of them. And that's probably the trick I was talking about. And so here is implementing the sum for the function, elevating all the elements to the power 2 and taking the sum and the module based on the Cartesian of the list here. I didn't know you can do pointers in Python. So I guess this is a pointer to n. And this is going to be the list of all inputs converted into an integer for the range k. And then sprinting max results. So it makes a list of all the combinations and then gets the max out of the list. So what I was missing is this product here to get the Cartesian of all the lists. And I also thought that I needed to use the sys module, and apparently you don't. Just use the input and then you print. I'm gonna see if this works later. Just see, I'm pretty sure it's the same problem, but I just want to make sure. Yeah, so it's cutting, or she is cutting the first element out. Yeah, I don't think maybe there's an answer here. Hmm. So this unpacks the list into its elements. I don't think this is correct. I think the other ones are probably correct. So this is more, looks like more my solution, or the solution I was going for. I was also using this. And then he's looping. But maybe, yeah, because I'm not sure if this takes into account all the different combinations. I think the other one is probably better than this one. Oh no, it's using product here. That's the difference. Didn't realize that. So the main thing I was missing is the product. I wonder how it's done in other languages though. There are probably a library as well for that in the other languages. I'm gonna put the solution here, just see if it passes all the cases. Yeah, so it is the solution. I probably should erase this though and come back another time to see if I remember. Or I should try it again. It's probably better. Not sure if I can undo this, but... So I think I'm gonna study these things here now. For a while. And I think I'm gonna do this every day, probably. Where I solve one or anywhere between 3 and 5 challenges, depending on how hard it is. And then as I get tired, I will study these topics here. I think that's a good way to have some balance. And then rest after that. And do it again. Correlation is a statistical measure that determines how closely two variables fluctuate. Positive correlation is the extent to which those variables. Spearman's rank correlation. Spearman's rank correlation measures the strength and direction of association between two ranked variables. It basically gives the measure of monotonicity of the relation between two variables. How well the relationship between two variables could be represented using a monotonic function. The formula for Spearman's rank coefficient is very complicated. Difference between the two ranks of each observation. Number of observations. So it's pretty much a relationship, measure of relationship between two variables. Now I'm gonna search for how to do it in Python. I think what they were asking is to get the Spearman rank correlation of a data frame or something like that. If you have two numeric variables that are not linearly related, or if one or both of your variables are ordinal variables, you can still measure the strength and direction of the relationship using a known parametric correlation statistic. The most common of these is the Spearman rank correlation coefficient. P, or I think there's a name for this that I forgot. I know in Portuguese and not in English, I think. Which considers the ranks of the values for the two variables. For example, consider the lengths and weights of a sample of 5 kittens. The ranks of the values are in the following table. Spearman's correlation is equivalent to calculating the Pearson correlation coefficient on the ranked data. Equivalent to calculating the Pearson correlation coefficient. I think this one I've seen. I remember studying this at some point. So I think it says rho will always be a value between -1 and 1. The further away p, I'm just gonna call it p because it's easier. It's from 0, the stronger the relationship between the two variables. The sign of p corresponds to the direction of the relationship. If it is positive, then as one variable increases, the other tends to increase. Yeah, so I remember seeing this on Kaggle competitions in order to figure out what variables are more strongly correlated, so you can remove one of them from the training so that the model doesn't overfit the data. You might want to use Spearman correlation if your data have a non-linear relationship, like an exponential relationship, or you have one or more outliers. However, Spearman's correlation is only appropriate if the relationship between your variables is monotonic, meaning that as one variable increases, the other tends to either increase or decrease, not both. Pearson correlation and linear regression. A correlation or simple linear regression analysis can determine if two numeric variables are significantly linearly related. Correlation analysis provides information on the strength and direction of the linear relationship between two variables, while a simple linear regression analysis estimates parameters in a linear equation that can be used to predict values of one variable based on the other. The Pearson correlation coefficient R can take on values between -1 and 1. The further away R is from 0, the stronger the linear relationship between the two variables. The sign of R corresponds to the direction of the relationship. If R is positive, then as one variable increases, the other tends to increase. So if it's negative, the other way. I think it might be a good idea as well to do Kaggle competitions and try to implement this stuff, because I'm probably not gonna remember just by reading this stuff how to implement it in Python. So just call this method from SciPy stats, and you compare by columns. I think all these methods are probably part of the SciPy library. The SciPy library is the core fundamental of all the other libraries in machine learning. I think it's SciPy, NumPy, and Pandas. the ones that are the pillars of every other one. So I think I'm just gonna write it down. I think this is enough for me to understand what it is. How to sum values of a data frame column until I think what I'm gonna do is go over these topics and the data engineer ones, and then I'm gonna do some Kaggle competitions. Probably one Kaggle competition and implement these things in the competition. And then I'll read them again, and that way I'm probably gonna be ready to pass the test. How to sum values of a data frame column until a specific value is reached. So the first thing that comes to my mind on this one is transform the column into a NumPy array, so it's faster. And then you loop through the NumPy array and you put an if condition. You sum the variables, sum the rows, and you put a condition to check if the value is the value that you're looking for, or up to the value you're looking for. And if it is, you just stop and return. So I think this one, I'm not sure why I put here. Maybe it was something specific about that. I think I'm just gonna briefly look at this. Let me read one more article on this and then I'll move on to the next. Spearmint rank correlation is closely related to the Pearson correlation, and both are a bounded value. If you'd like to read more, okay. Pearson correlation coefficient is computed using raw data values, whereas the Spearman correlation is calculated from the ranks of the individual values. So Pearson is raw data, Spearman is calculated from the ranks of individual values. Maybe that's a good thing to put here as well. Monotonic functions. There are monotonically increasing, monotonically decreasing, and non-monotonic functions. For a monotonically increasing function, as x increases, y also increases. And it doesn't have to be linear. For a monotonically decreasing function, as one variable increases, the other one decreases. Non-monotonic functions where the increase in the value of one variable can sometimes lead to an increase and sometimes lead to a decrease. So concave functions are non-monotonic, probably. Concave and convex. Spearman rank correlation coefficient measures the monotonic relation between two variables. So that's another interesting thing to write here. Perfectly monotonically increasing, non-monotonic relation. Suppose we have n observations of two random variables, x and y. We first rank all values of both variables. The Spearman rank correlation coefficient is denoted by RS and is calculated by. So probably under the hood, what the SciPy does is just implement these formulas here. Taking the inputs as two lists, I think, or Pandas series. computing the Spearmint rank correlation coefficients using Pandas. The various correlation coefficients, including Spearman, can be computed with the core method of the Pandas library. As an input argument, the core function accepts the methods to be used for computing correlation Spearman in our case. The method is called on a data frame. For n random variables, it returns an square matrix. Indicates the Spearman rank correlation coefficient between the random variable I and j. As the correlation coefficient between a variable and itself is 1, all diagonal entries are equal to unity in short. In short, this thing here. Another thing that I want to study is the Lagrangian as well, which is something that wasn't very clear to me when I was reading the Uniswap and stuff related to Web3. So I'm probably going to study this as well. Also, I can just do df.core method Spearman. It's probably worth putting this here as well. Yeah, I think this is very common on at least all the machine learning stuff that I saw so far. They do this correlation as one of the steps in the data cleaning and future optimization stuff. So I think I knew what it was, but I just didn't remember by the name. Probably. I can use ComSum. My data call one to get a logical vector of whether or not 4 has been reached in call 1. A funny name. Limit sum of column until condition is reached and return the index. I think you can directly add a column with the cumulative sum as. So it's just calling this method here. Not that hard, I think. Maybe I should study the IterTools library as well. I should probably spend some time going over the methods here. But first I'm gonna finish this list here. And then I'm gonna search for the Lagrangian so I understand better how it works. I think NumPy has a method for exponential functions, from where I remember correctly. I think it's np.exp. Yeah. But this is not. I think this is not what this is referring to. How to fit an exponential function to a Pandas series. I guess you can use the. It's pretty much machine learning. You can use the sklearn Keras layers to put the pandas as input. I wish I had. The thing is that I also had time. There's a time limit for the task, so I couldn't write it down very well, each one. Maybe spend a little more time on this and then move to the next topic. So can use polyfit to fit. This article we will learn how to do exponential logarithmic curve fitting in Python. Firstly, the question comes to our mind: what is curve fitting? Curve fitting is the process of constructing a curve or a mathematical function that's the best fit to a series of data points, possibly subject to constraints. Logarithmic curve fitting is plot of the. We'll be fitting both curves on the above equation and find the best fit curve for it. For curve fitting in Python, we will be using some library functions. NumPy, matplotlib. We would also use numpy.polyfit method for fitting the curve. And so this seems to be probably what they were asking about. This function takes on 3 parameters x, y, and the polynomial degree, returns coefficients of nth degree polynomial. So it takes 2 parameters and a polynomial degree of. So I guess you loop through the rows of the data frame and pass through values, and then whatever polynomial you wanna, whatever exponential function you wanna fit. And it's a numpy function. I think it's better if I put x, y degree. Okay, I think I'm just gonna jump to the next one. And I'm gonna do this one, and next I'm gonna search for the Lagrangian stuff. I'm gonna probably watch a video about that. I'm not sure if I'm gonna study this one. It's probably worth it, because I'm gonna have to, you know, at some point I'm gonna have to study this. It's just a matter of I'm trying to think about what is highest ROI on my time of the topics that I need to study. These tools and their built-in counterparts also work well with the high-speed functions in the operator module. For example, the multiplication operator can be mapped across two vectors to form an efficient dot product. The other thing that I've seen a lot, and I've been seeing more recently, is that Python being written as in the same way that C++ is written. And I think you can probably do exactly the same thing, because I suspect that the compiler of Python is gonna compile in the same way that C++ is compiled eventually. I'm not sure if you can do that in the other languages as well. I think probably not. That's why you have TypeScript and JavaScript, where type is the imperative version of JavaScript. But in Python, it seems like you can do it, at least some things, that it works in the same way that C++ works. Cartesian product equivalent to a nested for loop. Yeah, so as I was thinking in the Hackerrank question, I don't think there's a way to get out of this nested for loop for the time complexity of that question, to find the best combination, the highest value of the remainder. Permutations are length tuples, all possible orderings, no repeated elements. Are length tuples in sorted order, no repeated elements. Repeated elements. Oh, you can pass a repeat argument as well for the size of each one, if you're gonna call it on a string. It's hard to remember these things though when you're building something by yourself or solving a problem. I guess I have to read a bunch of times until it sticks in my brain, and I start remembering to use this in practice instead of defaulting to the first way I can think about it. So let me go back to the F1 thing. F1 score in machine learning with an example applying the F1 score in Python. Okay, so I can't read it. So look at elsewhere. The F score was called the F1 score is a measure of a model's accuracy on the dataset. It is used to evaluate binary classification systems, which classify examples into positive or negative. The F score, oh, I think I've seen something like this, where you have 4 different values, false positives, false negatives, then positive positives, something like that, where you have 4 quadrants to see if a model is good or not. I think that's what this is referring to. The F score is a way of combining the precision and recall of the model, and is defined as the harmonic mean of the model's precision and recall. The score is commonly used for evaluating for information retrieval systems such as search engines and also for many kinds of machine learning models, in particular natural language processing. So I think I can write this down here. Of combining the precision and recall of the model. Yeah, so usually whenever you increase the precision, you lose the recall, and vice versa. It's always a balance you have to strike. And I guess this is just because of the density of information. Because I think data is related to the frequency of computation in relationship to an observer. So the frequency of that computation determines the relationship of that observer in space-time in relationship to that data. So time and recall are related in that way, I think. That time is always relative because it's always dependent on the density of space-time. So that's why when you have lower recall, it just means that it's higher, the density is lower of space-time, I think. So you have more uncertainty in relationship to whatever the experience of the present moment determines the connection between past and future to be. Because past and future have to be born simultaneously out of the reference frame that creates the geometry of space-time. The formula for the standard F1 score is the harmonic mean of the precision recall. A perfect model has an F score of 1. Harmonic mean of the precision recall. F-score formula simply explained. Precision is the fraction of true positive examples among the examples that the model will classify as positive. In other words, the number of true positives divided by the number of false positives plus true positives. Recall, also known as sensitivity, is the fraction of examples classified as positive among the total number of positive examples. In other words, the number of true positives divided by the number of true positives plus false negatives. It's just very confusing. The reason why I think I wrote this down is because it's very confusing and hard to remember which one is which with these false positives and negatives. False negatives as well, I think. True positives classified by the model, the number of false negatives classified by the model, the number of false positives classified by the model. There are a number of metrics which can be used to evaluate the binary classification model, and accuracy is one of the simplest to understand. Accuracy is defined as simply the number of correctly categorized examples divided by the total number of examples. Accuracy can be useful but does not take into account the subtleties, I think, of class imbalances, or differing costs of false negatives and false positives. The F1 score is useful where there are either different costs of false positives or false negatives, such as in the mammogram example, where there is a large class imbalance, such as if 10% of apples on trees then should be, I don't know what this is, unripe. In this case, the accuracy would be misleading since a classifier that classifies all apples as ripe would automatically get 90% accuracy but would be useless for real-life applications. So maybe I should search F1 score Python. Just see the implementation. And then move on to the Lagrangian stuff. When using classification models in machine learning, a common metric that we use to assess the quality of the model is the F1 score. The metric is calculated as F1 precision recall. Just same thing. Also, it's just a sklearn formula. I should probably write this down here. I think this one I'm also gonna search for polyfit Python. I think I will search this and I will look it up later. I will look at the source code later, investigate the source code to understand how they are implemented. And Spearman, I think it's just from the data frame. So I think I'm going to look at the Lagrangian and then I'm going to take a break. Lagrangian. First like this and then with Python. In physics, Lagrangian mechanics is a formulation of classical mechanics founded on the stationary action principle, also known as the principle of least action. It was introduced by the Italian French mathematician and astronomer Joseph Louis Lagrange. Lagrangian mechanics describe a mechanical system with a pair ML consisting of a configuration space M and a smooth function L called the Lagrangian. By convention, L equals T minus V, where T and V are the kinetic and potential energy of the system, respectively. The stationary action principle requires that the action function of the system derived from L must remain at the stationary point, a maximum, minimum, or saddle, throughout the time evolution of the system. This constraint allows the calculation of the equations of motion of the system using Lagrangian equations. It's very complex and difficult to understand. I understand it in a superficial level, I think, but to really understand it, I don't think I do. Like all the physical implications of this is very difficult to understand, especially on higher dimensional planes, because then obviously you can visualize it. So suppose there exists a bed sliding around on a wire or a swinging simple pendulum. If one tracks each of the massive objects as a particle, calculation of the motion of the particle using Newtonian mechanics would require solving for the time-varying constraint force required to keep the particle in the constrained motion. Reaction force exerted by the wire on the bead bed, or tension in the pendulum rod. For the same problem using Lagrangian mechanics, one looks at the path the particle can take and chooses a convenient set of independent generalized coordinates that completely characterize the possible motion of the particle. This choice eliminates the need for the constraint force to enter into the resultant system of equations. I think I'm gonna look at the Python implementation of an example of a Lagrangian. I think Lagrangian is more a constraint. It's based on constraints of different variables should simplify the solution of problems, I think. Library allows to compute Lagrangian analysis with Python. Physical quantity units. Checks if the unit can define this type of access. This is probably paid. Yeah. I think I'm gonna take a break. I'm probably gonna watch a video about the Lagrangian off stream. And then I might come back. When I come back, I'm gonna continue doing these exercises here. Oh, it says on the exercise that you have to use ether tools. I didn't see that. Up here. So I think I will try this two next time. I think after I do the hard ones here, I'm probably gonna do the lead code hard ones, and then I think I'm gonna do the code wars, because the nice thing about the code wars is that you have the rankings, and I'm very competitive, so I like this kind of game like dynamic. So I think I'm gonna do the hard ones here, the hard ones in lead code, and then I'm gonna do a bunch of them. If I can solve these ones, I'm gonna come back to them again after I go through the Code Wars challenges. And then probably I'm gonna also do Kaggle competitions in between. And then after I do that, then I will take the tests on the Turing site. So yeah. See you until next time. See you.